Welcome. This is our Friday webinar, and today we're going to talk about data types in DataGraph. As always, I have fun kind of preparing for these and thinking about what am I going to talk about, because to some extent, DataGraph has somewhat of a simple model on the surface if you look at the types of data that you can import. But there's actually quite a lot of different topics that we can talk about here. And when you really get into the details of how the program is set up and how you can convert between different data types and how they work, there's actually quite a lot of material there. So to start, I wanted to just talk a little bit about why do we have data types in the first place. And one of the things that I did to prepare for this is I did a bit of searching to look for books or articles that talked about data types within programming and databases. And actually, I didn't find a lot of books that directly addressed that issue, but I did find this book that was published, I believe it was in around 1985, maybe 1986, called An Introduction to Data Types. And I actually thought this was a very helpful book for those of you who might be interested in this. And they talk about, or the author, Cleveland, talks about all types of different data types. And one of the things that he does is he defines why do we use them and gives three essential ideas behind why we have data types. And one is to understand and organize our data and objects so that we can then, second reason, to see and discuss various properties associated with data types, and also to help us to detect errors, because data types are used not only to define a category or a type of data, but also to define what's possible with that data. And DataGraph has various error detecting capabilities built in that I'll show you just a couple of quick examples of that as we go through the webinar. If you think about what common data types are in general, then programming languages tend to have a set of common different types that you'll see in different programming languages. You have integers, you have Boolean, you can have different precision numbers. Text-based data types are sometimes also divided between individual characters as well as string representations. If you go to the other extreme and think about what are data types when you have a spreadsheet, are there data types in spreadsheets? Well, when you are just typing information into a spreadsheet, you don't have to define what the type of the data is. This is one of the things that makes spreadsheets very convenient, as opposed to having to type things in a programming language where we have to strictly define what the data type is for every piece of data that we have within our program. But the reality is that spreadsheets, I'm sure as many of you are aware, have a data type associated with individual cells. And spreadsheets are trying to interpret the data that you provide to encode, or to, it's maybe not quite the right word, but to specify what the data type is within a specific cell. So you may have had the situation, I know I have, where you have maybe worked with a spreadsheet and you have some data that you put in numbers, but one of the cells had previously been a date, and it still thinks that that cell is now a date field. And that can be a little bit frustrating. So if you don't have a strict specification of what the data type is, then you can run into trouble. And DataGraph in some ways goes in between the two of these, where we have, you do have to specify for every piece of data that you have in DataGraph what is the type of data, but so there is more specification than with the spreadsheet, but it's a lot simpler of a data model as compared to programming languages. And one of the things actually that in the book that I mentioned that he talked about is, well, why do we have, for example, for numbers, all of these different types of numbers that can be represented, from integers to Boolean and so forth? Well, the reason for that largely was to save space on our computers. Integers obviously take up a lot less space than do larger numbers, single precision, even double precision numbers. Um, and, and yet with modern computing, that is in many cases much less of an issue. And so in DataGraph, if we look at the data model that we don't have different types of numbers specifically as that you have to identify when you enter your data. Rather, we have a number column where you can have integers or larger numbers represented there. We also have a text type. So if we go back again to the prior slide where you have both individual characters or string representations, we have a single text column. Now there's also other derivative columns that we have, and I'm going to go into more detail, but for now I'm focusing really on the data as you're inputting it and the column types that we have in DataGraph. So to go just a little bit further, if you want to then, again, look at the general numbers versus text, well, let's talk just a little bit first about numbers within DataGraph, because there are different columns that are all numeric and have numbers behind them, but are handled in different ways. And the first one I want to talk about here is the row number. This is a very special type of number. This actually is an integer, what's saved behind the scenes. And if you haven't used the row column number, it might just be something you see on the left-hand side and you haven't utilized it. I'm going to talk a little bit about a little bit more about what this is and how you can use it. But essentially what the row number is a row column, is it's a row counter that does not have a predefined length. The length that you see on the screen will depend on what the other data is within your spreadsheet. So when you're, for example, using it in an expression, you'll have to define the number of rows that you want if you're only using the number column. So let me give you a quick example of that before we move on to these other types. Now you should be seeing a data graph, a blank file. And if you look over on your list on the left-hand side, there's always one entry here, and this object that I can click on is something that doesn't move around. So if I'm adding other columns or I have other data here, this is always going to be at the top. And you see it has this number symbol. Again, this object represents the row number, which to start, I would need to add some data to even see this. So let me, I'm going to click this button to create a number column. So this would be my standard number column. And let me type in just 1, 2, 3, and you'll see how on the left-hand side, there is now a 1, 2, 3 there. This column here is this row number. And I can use this row number column in expressions. For example, if I want to create a list of numbers rather than typing them in, I can add an expression column. And let me just delete this number here. And I could say the expression is just going to be my row number and then specify the number of rows that I want to see. So if I wanted 10 rows, then I can just very quickly create a list from 1 to 10. This is actually very handy for a number of different things. Again, I have to define the length because the row column doesn't have a length associated with it. But I could use this in more complicated expressions to create lists of different types of numbers. So for example, if I wanted to have just even numbers, then I can multiply it by 2. If I want to have odd numbers, I can subtract 1 from that. And in fact, in our online manual, there's a list of a whole bunch of different types of expressions that you can use to generate big lists of numbers of varying type. We have, in addition to the row number, these other types of columns that you see here. Number columns are the ones that I just created. Date columns are also a type of number. And binary columns, it's another column type that DataGraph has that you may or may not have had the opportunity to need or use binary columns. But there are differences between the three of these. And in fact, let me go to the next slide here just to show a little bit more about what the differences are. The row number is an integer and it's saved that way within the program. Number columns and date columns have a similarity in that they have both a text and numeric representation saved of those types of numbers. I'll give you an example to show you what that means. A binary column is one in which there is only a numeric representation saved for that number. So let me give you again, a quick example to show you how we would go back and forth. And what does that mean when I say there's both a text and numeric representation to these types of columns? So if I go back to my DataGraph file and I add in a number column, so here's going to be my number. I can type in values, right? I can also type in letters, and if I do this first, let me just type in the letter A. Oh, actually, I did not create a number column here. I created a text column. So I can show you very quickly one of the things that you can do here is to very easily convert between these types. So this is one of the things that DataGraph does really well. That if you have a text column, you want it to be a number column, then I can right-click on the column header and I can select convert to number. You can also do this conversion from the gear menu on the column list of the list of data that you have within your file. So I'm going to convert this to a number. And one of the things that you'll see is that this letter A is now red. And I can also, I can type in other letters and you'll see how anything that's not a number is going to show up as red. This is an example of error checking. I mentioned that before, that one of the reasons we have data types is to look for possible errors in how our values can be used. So for this number column, right now, lowercase a and uppercase b have no numeric representation, so they're showing up as a red value, as an error. However, I could change this. So one of the things that's really handy that I use for a lot of different situations is that I may have a text string that I would actually like to be represented by a number. So I could do this in a value, create a variable down here where I'm going to say that the letter A is equal to some number. There we go. And now what you'll notice is that the letter A in my number column is no longer showing up red because it no longer is an error. It has a numerical representation. So again, behind the scenes, this column itself has saved both the letter A, but also has saved the number 46, which I've mapped here down below using this variable. Now, a lot of these columns also have the ability to change what you see, and number columns and date columns both do this, where I can expand the my object on the left-hand side. And right now you see that I'm displaying the entered value. So this is displaying, again, the text that's been entered to this number column, but I could change this to show me a numerical representation of all of the data that I have in my column, and can even use, there's various formatting options. If you wanted to have something more look like currency, for example, I can do that. But again, these two representations are both saved for the number, both the string representation, which I can have displayed, or the and the numeric value behind the scenes. This means that I also can do some simple math within my number columns themselves. So I could say 1 plus 5, and right now I'm just seeing that text that I've typed into the number column, but I could also change this to display the numeric value behind the scenes. So now it's showing me the number 6. I wouldn't necessarily recommend doing complicated math within the column itself. DataGraph is really meant for doing higher level calculations, but I know I have found that for various things where I'm doing some type of data entry, it can at times be really handy to be able to just type in some simple summations within this field. And then if I click on that field, now it's going to show me that text representation. So I see now here the 1.5, and I can, at 1 plus 5, I can go ahead and add more to that to change what that number is. And dates are, again, similar then to number columns because of the way that we can, again, store them as both text you have both the text value that's underlying, and then you have the numeric value that's underlying. So let's go ahead and just create a simple date column to show this a little bit. So dates are sort of interesting because, again, there is a number saved behind the scenes that you may encounter depending on what you're doing with the date value. So here, for example, if I just type in 2001, this is a way to format dates. Now, there's an error here right now because within my date column, it's telling me it's specifying how I want to format this. And the format that's shown is month, day, year. Now, I typed this slightly different. I typed this as year, month, day, using a colon in between. This is actually our native format that you can use for dates, for masking, and using it in other variables. But we don't have that set necessarily by default. So there are other options here as to how you specify this. And you can see one of the type options is the DG format, which is the format that you see here. So now the date string is understood, and I could type in some other date values. And let me just do one more here. Oops. And, okay. So these are all understood. I don't have any red showing me that there's any errors here. But again, I can display this differently. If I wanted to change the display, I can go here into any of these. And now this is just a format statement. It's not changing anything about the underlying value that's here, but it's allowing me to very quickly change what the date looks like to whatever my preference is. For those of you who are familiar with the ICU formatting, this is one of the really nice things about dates within the program is that you can actually use these format strings to specify exactly how you want both the output and the input. So for example, if I want to show just YY is a code for just the last two digits of the year, or I can type YYY to have the entire year be shown. And there's a whole list of standard ICU format strings that are out there. This is not a system that we have come up with. This is a standard system that's available. If you go into the help menu for the date field, you'll find some links to some of the various format statements. But again, you can also have if you go to the input, there's also an ICU format string that you can use for inputting. This is actually really flexible because you can combine format strings with other text and a date that's in almost any format. There's been very few times I think that there's been a date format that I haven't been able to come up with a string representation that would allow me to import that. So if that's something you're ever having issues with, let us know and we can try and help you with that. But anyway, so for now, if we go back to our date and we'll go ahead and just look at the entered value, one of the I guess properties associated with numbers in general is that numbers can be used in expressions. Let me add an expression column, therefore, and just put in the date. And that will return back for me the numeric representation that is being saved for that date. So we have the string representation, we have the actual number that's saved, and so this is also a date, but it's the underlying way that we represent dates. And the procedure here, or the way that it's done, is to save the date as the number of seconds since January 1st, 1970. This was something that was a convention that was came out of the Unix operating system. And so you can see here, this number is very big because this is the number of seconds since 1970. And if I even, let's see, I should be able to do this, 1970, 01, 01. If I put in the January 1st of 1970, the date numeric value associated with that is a value of 0. So I know sometimes this has thrown people off when they're using dates in various ways, or maybe in an expression, and you get this return this large number back. But now you know what this means. And in fact, for any expression, you can actually tell it that I want to display a date, and you even have some format strings available to you for how you want that represented. So a lot of flexibility with using dates, and you can use dates again within calculations. You can use them in expressions because they are numbers. You just have to remember again that these are that it's the number of seconds since 1970. So let me just comment a little bit on binary columns, because I know this is something that some people will use, others won't. But if you look in the other drop-down menu, this is where we have a number of derived columns, but we also have this binary column type. And again, binary is slightly different. It really only will save a numeric representation. So if you're actually, yeah, for example here, if I take 1 plus 1 and I type that in, it's going to just evaluate 1 plus 1 as 2. It's not going to save that underlying 1 plus 1 within my file. And it also will be limited as to when you're doing mapping, because numbers also do have this underlying string saved. Number columns can be used in other mapping types of columns, whereas binary columns will not be able to be used for that. So I don't want to go into too much detail on binary columns. These are columns that actually also will get created when you're importing from MATLAB. I believe that natively will create a binary column automatically if you, for example, drag and drop those in. I can also again, quickly convert these. If I wanted my binary column to be a number column, then I can go over here and I can say, actually, I guess I have 2 steps I would have to do here. I would convert to text, because you'd start with the string representation, then I would convert to number. So you can pretty easily go between these different data types. Another thing that's handy, in case you have a lot of columns that you want to convert from one type to another type, I can highlight several columns at a time, and I can go ahead and use this gear menu here, and I could convert all of these to number columns. So now all of my columns have been converted. I can also just undo that. So let's see. So we've talked about numbers, we've talked about dates a little bit, we've talked about the binary representation. The columns that you see, these are the ones that we talked about. On the right-hand side, there's a little bit more information on text columns. So text columns can be notoriously difficult for large amounts of data, because they can take up a lot of space, and they can cause files to slow down. Back years ago, I did a lot of work in access databases. And this was one of the notorious things that would happen if you had data that you pulled in where you had a lot of text strings that were repeated over and over and over again. Say it was just some categorical string that you had a big data table and you had the same data, so maybe data for states over multiple years, and the name of the state was just repeated over and over again. That could really, really slow things down. One of the things that we do in DataGraph is we try to be very smart about handling data like that. As a result, text columns behind the scene, there is more going on for those columns than you necessarily see. And that's just what I'm trying to simply represent here, that text columns have certainly, the simplest storage is to store each entry. And even there's two different ways that can be done depending on the size of the file. But what we also do is there's a behind the scenes indexing of text data that can really speed things up when you have a file like this, where you have a lot of text values that are repeated over and over again. So don't be afraid, I guess, as part of the message, to bring data like that into DataGraph. I know from my experience with databases, we would have to take that data and convert those text strings using some type of a lookup into a numeric value and use that as what we would save all our underlying data as. DataGraph does all that for you. And in particular, if you're doing pivoting, that's one of the things that DataGraph will do. So to give you, again, something more concrete than just me talking about it a little bit here, we'll create, again, a text column here by just clicking on this icon. So this will be my text data, and we'll just do something really simple. So again, if I'm repeating values over and over again, I may have some type of category that I want to display, and these different categories have different values associated with them. And here's my data. So if I'm doing this in a pivoting, now imagine that I have not just 9 rows of data, but that I have 900 or 9,000 or 90,000 rows of data. And here's my number. Well, pivoting, I know if you're not used to pivoting, this can be something that might feel a little bit confusing to do, but actually there's a lot of shortcuts to make this easy. So for example, when you're going to do a data pivot, you will want to have your categorical data on the left-hand side and your numerical values on the right-hand side. So even just with these 2 columns, I can highlight these 2 columns and click on the pivot command. That's all I had to do. If you want to see the underlying calculation that was done, then I can go and expand the pivot command, and you'll see the data has been summarized over these 2 categories. By default, it's just doing a simple count here, but I could also, in fact, this is sort of interesting because I did do this as a number column. I called it number, but it's actually is text. So I convert this now to a number column, and now it's summing. So what I inadvertently demonstrated was, again, how different data types are able to do different things. So in this example, it's counting it's actually just took my text column and it's counting the number of rows that are A and the number of rows that are B. So that's actually, in fact, is one of the things that I wanted to comment on. One of the things that DataGraph does that I think a lot of other programs in kind of this similar, that do other similar things don't do, is DataGraph allows you to do not just use text data for labels and things like that, but you can use text data to actually analyze the text data. So I can do, I could actually even just take my simple column, just select that one column, click the pivot command, and that's basically doing the same thing. It's counting the number of times A occurs and the number of times B occurs. So that's a really easy thing to do, and a very, if you're working with categorical data, it's very powerful. I find this very helpful for if I have data, for example, across a large number of categories, and maybe every category should have been analyzed 100 times. I can very quickly do a count of each of those to verify that, in fact, the data has been generated the way that I think it should have been generated. But there's obviously there's a lot of other things that you could do with the text data. But again, I think that's sort of a unique thing that DataGraph is able to do. So if I go back here now to this example, let me go ahead and click on this first file. But now I'm going to, again, change this from a text column to a number column. Now what it's going to do by default is, because numbers are able to have calculations performed on them, it's going to give me a different list of possible things that I can see here. So, and again, this is because it's a number column. For example, I can calculate the mean and the standard error on the mean. If you go back to the pivot command where I just am using this categorical data, there's less options available to you. I can calculate a percentage here. For my two graphs, where I have one that's based on categorical, one that's based on numerical, again, I get a different drop-down menu depending on what I want, what the data type is that's available to me. And what's nice here is how quickly I can change between all of these different types of calculations. So if I want to see the minimum, or I want to see the maximum, if I want to see the range of data that's shown, I can easily get that information. And all of this is also information that I can then pull back into my data table. And if you've never done this before, I'll just demonstrate this really quickly because this is such a nice functionality. If you click on the gear menu, I'm not sure if this window, the way that I'm sharing this, if you'll see it, but I'm clicking this gear menu, and then I have the option of, for example, extracting all pivot columns, and then it's going to show me the value that I have picked here. And I can change whether my calculation is the mean or the max, and it's going to change the value that's being output within my data table. One of the other things that I wanted to talk about was the ability to encode different data types between numbers and text. And this is, again, something that I think is really nice that DataGraph allows you to do, and can very easily do this type of encoding. So, and you can go back and forth from, I can encode numbers to text, and I can encode text into numbers. So there's a lot of flexibility there. Let's go back into my DataGraph. Okay, so for example, let me add into this file another, and oh, actually, sorry, I wanted to do this. I wanted to skip a letter. And we'll have some more data here, and notice, again, in the DataGraph way, everything is, updating as I do this. So if I had, for example, these three text categories, I have A, I have B, and I have D. But say for some reason I wanted to have these plotted on a numerical scale, and I wanted my text value to actually be a number associated with it. If you go into the text object that represents that column, then there is a values drop-down menu that I can use to map these text strings to a numeric value. Now, some of you may also have used the map column, but this is a very simple way to do a mapping from text into values. So for example, click on this and I get a list of different options. One of the options is to just have the row number be represented. And if I click that and display it, you'll see now that that's the number that's being encoded into each one of those row values. Now for this example, that doesn't really make much sense because I want my encoded numeric value to correspond to one of my letter values. Let's look at one of the other options. I can go to sorted number, and what that's doing is giving me the number 1, the number 2, the number 3 based on the alphabetical sort of my 3 values. So that's pretty useful because now it's, again, it's making sure that the same number is always going to get the same letter is always encoded with the same number. If I go now to the sequence number, in this case, this is actually giving me the same thing. So let me actually go back to the text representation to show you how I could make this different. So if I go all the way to Z, for example, at the end of the alphabet, and I change this now to sorted number, notice it's going to sort alphabetically. So I get A encoded to 1, Z is encoded to 3, and then I have my final letter, I think that was D, encoded to 2. So again, I can switch between sequence and I can switch between sorted, and this allows me to be able to, again, use these values as numerically in various ways. So that's a really easy way to encode from text to number. There's also a mapping that you can do within the text column itself where I can specify a string value to specify what I want my string to be mapped to. So if I wanted my letter A to be mapped to the number 2, I can just type these in. So this can be, really handy if you have, again, some type of data where you're having to do this, and this is just built in directly into the column itself, so it just stays with the column. Now there's other ways that we could do the same thing. I showed you earlier how I created a variable and I had the lowercase a be the variable 46. I could actually do the same thing here. That would be then a global variable that would be available throughout the program. So this is a nice way to create just a local variable within that column, that A would be 2 and so on. We also can have the mapping column be used for this. So that's a completely another way to do this. So if I go back out and I just go ahead and go back to none, the way the mapping column works is by allowing you to have a separate lookup table. So in this case, first of all, I created the map column. I can, within the map column itself, also type in a conversion where I can go, or again, type in the mapping directly. So if I have my A, Z, and D, I could map these not only to numbers, but I can map to text. So if I wanted to map to numbers, for example, then I would say text to number, and I have to select the column that I'm mapping. So now I have a mapped version of my text that shows me, whatever value I type in here is going to be the one that that shows up on the table. So again, very convenient. And you can, at any time, you can change what column you're selecting here. You can make copies of this map column and use this in other places. Another way of doing mapping is to also use individual columns, where you set up a set of columns and you'll map between them. So I'm not going to do that specifically here. I think we've done that in some other webinars, and there's other information on that. So that's really more when you have a data table that you want to connect to another data table, you can map those two to one another. But again, sort of paying attention here to the fact that I have this, the type that I need to specify. What do I want this output column type to be? Because every column has to have a type associated with it. And okay, so we've encoded text into numbers, but again, how would we then encode the number into text? Well, that's something that I can do within the map column itself. So let me, for example, let me go ahead and just do a different use case here, where if I say I have some numeric values, oops, I'll actually create a number column this time. I seem to keep clicking on text column. So say you have some grades, and these have different values associated with them. Then these are things that I can, again, I could map, you know, if my number to text, if I have a 90 and my 90 is an A, and you can actually see even within this table how I've specified I want this to be number to text, and I typed in some text values here, so it's showing up as as red because it's checking and these are not numbers. So if I would be mapping my grades, then that would then again show up as the letter A. And so there's a lot of different ways to move between these various data types and to be able to encode one into another. One of the other things I wanted to make sure that I got to was to talk a little bit more about the different commands and the way in which different commands handle numbers versus text data or categorical data. For example, if I just have numbers that I want to plot, then obviously my plot command is going to be a way that I can do that. Actually, we'll make this our X column and our Y column, and we'll type in some numbers here. Great. So the plot command, for example, is always going to use numbers, and the points is the same way. So I can create a plot command. I can use that in another points command. These are commands that are designed to work with numerical values. There are other commands that are really designed more to work with categorical values. And the one in particular, what I wanted to sort of point out is the difference between the bars command and the bar command. So if you go under the command menu, again, I'm not sure if you can see this the way I'm sharing my screen, but under the command menu within DataGraph, there's an add bar and an add bars. Actually, maybe I can just take a screenshot just in case you can't see it. And let's see, I'm going to add a blank graph and just paste this in here. So I go under the command menu and you'll see this add bar and add bars. There's actually a pretty good description, I think, of the difference between these on our help on the knowledge base. That's under the article on how to create bar graphs. But the differences here are relevant to what we're talking about in terms of data types. So if I create, for example, a bar graph with just a column here of X values, then I'm going to see an X axis that is also numeric. If I instead, let me convert this to a text column. Actually, now it's just not showing anything. We'll go ahead and do this now here. So now what I've done is I'm plotting my Y values along the Y axis, and my X axis is actually a text string that is showing my bars across the top. And I think actually if I convert this to a number, then notice how that doesn't change anything in terms of this x-axis, because this command is designed to really show things on a categorical axis when you have a label specified. So in this case, the label here is the string representation of my x value. So I think even if I change this, for example, if I change this to 3 plus 1, then this is again where you have these dual representations of numbers. It's going to show 3 plus 1 as the x-axis value. So if you need to do that, that's kind of an interesting way to be able to show that. But what if you actually want to have these bars located on a numeric axis? Well, that's where we would actually use a different command, because again, the bars command is really meant more for categorical data. It does these side-by-side bar graphs and groups them according to categories. But there's another command, that's the bar command, that will utilize the numeric values and plot bars along that numeric axis. So let me just go ahead. I'm going to, in this graph, create a bar command, and the value that I would like to plot is going to be this y value here. The other option is this where option, and this is essentially where on the x-axis do you want to have these shown. By default, if I don't select anything, this is that row column that we started talking about in the beginning. It's actually selected by default the row number, and therefore these bars are located at 1, 2, 3, 4, and 5. It's just the sequential row number. If I change this to the x column, now it's going to use the numerical value here in order to plot these bars. So if I set this one at 0, then it's going to show that numeric value associated with that. And the bar command is one that it's another one of these commands that I think in some ways appears relatively simple, but it's almost deceptively so, because there's so many different things that I can do with this command, because I can also change the extent to which my bars, where they begin and end along the axis. There's a lot of different things that I can do. And again, it's more numerical as opposed to the bar command, which really is more of this categorical type of command. And the pivot command also is another one. And I think I paused my screen sharing for a moment that I wanted to check the question and answer. The question was, it looks like someone had a storm. They had to turn off the internet. Will the webinar be available on YouTube? Yes, we will. We have been recording these on YouTube. In fact, we posted one of our webinars from June this week. We're going to post the last one we did in June. Should be up later today, and our webinar from last week should be posted, I would think, by Monday. So we're catching up a little bit on those, and working also on improving the quality of the webinar. So hopefully this one is going to, as we do these, we're hoping to get better and better at it. So we'll increase the quality of the webinars themselves. This difference in how the axis is shown, we also see this with date, with the date axis, where again, dates are numerical, but they are something that is essentially, it's a numerical axis, but it is showing you a view of that makes more sense depending on what the range is and how you're using that. But again, it really is a numerical axis. So for example, let me screen share a different file. This is a file that's in the online examples, and this is a time series of data where we have minutes here on the left. We have minutes also shown here. We have values that we're plotting, and then we're using different different commands in order to filter and combine the data in different ways. So we're calculating different moving averages. So if you look at the first graph here, this is showing me just the individual values where they are, there's a lot of noise. If I go to the next graph, then this is showing me daily averages. And if I go to the final graph here, this is showing me a monthly average of each one of these numeric values. And we're doing this all with the pivot command. And the pivot command really does some, has some really handy functionality built in for dates, because you can specify that you want your calculation done on different averaging times, for example, as is done here. And you don't have to do anything else fancy. So for example, here I have this pivot command where I've chosen the rows to be this time column. This is in minutes, or it says in minutes. This is really a, an underlying column. I have my actual values that I have for my y-axis. I'm calculating the mean. And then I told it in this section below that I want it to show me values here in months. But notice how this drop-down menu gives me all these other options. If I wanted this to be quarters, if I wanted this to be years, now there's just one value because there's 1 year of data. If I wanted this to be weeks, I could go ahead and have that be an average. And all of these options are built in. One of the things that's really handy is you can even do a month number. So if you wanted to do an average of every, if you have a long-term data set and you want to average every January to know what a value is for the mean and standard deviation in the month of January, that's something you can do very easily with the pivot command using a date column as input. Because again, it has all of this here. Now this data set only has 1 year, so again, it's not really going to be that interesting in terms of being able to show this. But there's other data sets that we have that do. There's a video, in fact, we did on looking at sea ice data that does some interesting, that shows you how to use some of these functionalities. That's on our YouTube channel. So here again, we can go back to the monthly average. And again, the menus themselves are dependent upon what data type we're actually using. If I didn't have a date, if the column I was inputting was not dates, then I wouldn't see these options here. I would see different options for numbers. In fact, the pivot command, when you have strictly numeric data that you're inputting, then it will allow you to bin that data in various ways. The pivot command also, you can do things where you pivot on years on your individual columns, and you can pivot on quarters or weeks on the individual rows. So you can have a data set that you can then really aggregate it in time in various ways. I found that also to be really handy. So with that, I'm going to go ahead and start wrapping up today's webinar. I wanted to see, I know there was some activity on the chat. I'm just checking to see if there's any other questions that anyone might have before we go ahead and wrap up for today. And I think that is about it. So I don't see anything on the chat. Next week we're going to be talking about masking within DataGraph, and this is definitely one of the things where if you're needing to manipulate data, you want to look at data for different categories, or do different fitting on different categories of data, all sorts of different things. The mask is really a very powerful way to be able to manipulate data and hone in on a particular data set. And because you can nest them, then it allows you to create filters that are have simple statements within each one, but can do relatively complicated things when they're combined within in multiple commands or multiple masks. And I think that's about it. So we'll go ahead and wrap up for today. Thanks so much, everyone, for joining. And as always, if you have any questions, you can contact us on the forum. And I hope that everyone has a great weekend. Thanks.